So in the last session we were discussing about the user defined data types, and we saw how the typedef is used in order to rename an existing data type into another data type, or actually what we are doing is an existing data type which is already available in C is renamed with another string, like in this case it is uh, typedef int age. So from now onwards, if you use the word age, or if you use the string age, then it will obviously mean it is an integer. So you can define variables like this, that is age ab. So this a and b will be of type age, but age is of the type int. So a and b will be indirectly be of the type integer. So then there is an array of floating point values is defined using the typedef float height 100. So 100 elements can be stored inside the height type. So then if you define two variables with this particular expression, that is height men comma women, then men as well as women, both these variables will be of type float with an array size of 100. That is, men and women will be an array of floating point values with the array size as 100. So this is how the user defined data types can be used. So if on the other hand, if you have to define men and women as floating point values of 100 size, then obviously you will have to type float twice, that is float men 100 as well as float women 100, or at least float men 100 comma women 100, at least those things you will have to write. But that particular repetition of this size can be avoided if you use a user defined data type using the typedef. So that is one of the advantage. So another advantage of using the typedef feature is that it is much more convenient when defining the structures. So a particular structure can be defined with a new name, or it can be declared with a new name using the typedef. So that is, when a new structure type is defined with a typedef, the keyword struct can be avoided while referencing that particular structure. So whenever you want to, or you are creating new variables of that particular type, that particular structure type, you can avoid using the keyword struct. That we have already mentioned about this in the previous class, but we are elaborating about it. So whenever you are creating a new structure type, or whenever you are defining a structure, obviously you will have to use the keyword structure, because the compiler must know that this particular thing is going to be a structure. Then whenever you are declaring or defining new variables of that particular structure type, declaring new variables of the structure type, in that case also, if you are not using the typedef keyword, so in that case you will have to use the keyword struct again. So that is the advantage of using structure along with the typedef. So like this, typedef struct, then the double braces starts int admission number ADM number char name 40 float marks, then student. So what we are defining is, we are defining a structure of type student. But in the other case, if you are using only struct, then you can remove this typedef, then struct student, then you can include whatever is required within the curly braces, and then end it with a semicolon. So then student is a structure, but whenever you want to define two variables of the type student, again you will have to use the keyword struct student mech comma civil. That will create the variables mech and civil as of type this particular structure student. But when you are using this typedef, there is a slight change in defining this typedef using defining the structure using this typedef, then struct is the keyword, then the elements within the structure, then the name for that particular structure type. That is actually what we are doing is we are renaming this particular structure as student. So whenever we are using the variable student, or whenever we are using the keyword, or no, actually it is not a keyword, it is a string, it is just a string. If you use a string student inside the same program, then obviously it means that it will be related to this particular structure. So then student make civil. So we avoided using the struct keyword here since we used this typedef. So that is the main advantage of using the typedef, or the main advantage of the user defined data types. You don't have to use the keyword structure again and again whenever you want to declare new variables of a given particular structure type. So then how this can be implemented, that is the typedef can be repeatedly used inside another data types. That is it can be used repeatedly to define one data type in terms of the other user data types also. That is, a structure is a user defined data type, and if you create a user defined data type as structure, then that particular structure, that particular user defined data type can be reused inside another data type, another structure. That you know that one type of one structure can be used inside another structure. So the same way the typedef can also work. That is, typedef struct, then into day, into month, and into year. Date. So date is the type, the user defined type. So date, the value or the string date is the user defined data type, which consists of 3 elements, day, month, and year. All the 3 are of type integer. Then there we are defining another structure of student which is of size 100, It is an array of size 100. So in this array, this particular array is an array of structures. So, and within this particular structure, the different elements are int, admission number, char, name, float, marks, date, bdate. See, date, bdate. We are not using the struct keyword here, because this date, this particular date, the value or the string date is used in order to denote this particular structure. This particular structure is denoted using the word date. So date, bdate, and date, ADM date, that is admission date. So these two are of structure type, these two elements are of structure type, and both are considered, or both are initialized, or both are defined as type another structure type, that is the date structure type. Then we create this student 100. So this means that the student 100, that is a 100 element array, is student. Student, or the variable student, is a 100 element array of structures, and the structure within that particular array is this one. And in this case, these two elements, bdate as well as ADM date, both will be of the structure type this one. So then we define two variables of type student. So student, mech2, civil2. So in this case, mech2 and civil2 will be having an array of structures with 100 elements in it, and the structure that is available within this particular array is this one. This particular structure is available there. So that is how the user defined data types can be employed with structure types. It is easy in terms of defining the things, defining the different variables, easy readable, in an easy readable format we can define the different variable types of structure. Actually the variable types should be of structure. So if you are giving a structure, or if you are creating a structure as a date, obviously you know that in a date there should be the day, the month, as well as the year. So that is how this works. Now the next topic that we will be discussing is about the storage classes. The storage classes are actually the different types of variables or that is being used inside our C programs. In the case of C programs, we use a number of different variables, and we have seen that for each variable there is a data type. The data type can be integer, floating point, long integer, character, etc., etc. So that is the data type. There is another thing that is also associated with a variable, that is the storage class. The storage class is nothing but in a particular program, what is the scope of that particular variable and what is the life of that particular variable, how it can be defined or how it can be controlled for the proper working of that particular program. That is what is defined by this storage classes. So before going into storage classes, let us see what is the scope rules of variables, or what is what do you mean by the scope of a particular variable. The scope of a particular variable is the range of code in a program over which a variable has a meaning is called as scope of the variable. That is, if you are defining a particular variable at some point in that particular program, you know that whenever you have to define or declare a new variable, it should be just after the opening double braces. The variables should be declared just after the opening double braces. So if you define such a variable, say x, int x you have defined in a program just after opening the double braces, then wherever that particular scope, that particular variable is available, that is defined by the scope of the variable. Whether that particular variable is available throughout the program, or is it available only within that particular function, or is it available only within that code block. That is, code block is, suppose there is an if loop or there is a while loop. If there is a while loop, inside the while loop you know that we use curly braces, opening curly braces as well as closing curly braces. So just after the opening curly braces, if you put a variable, is that particular variable available throughout the program? So that is defined by the scope rules. So the scope of a variable decides as to how it can be accessed by the different parts of the program. So that is the scope. So whether a particular variable is available throughout the program, or which parts of a particular program can access that particular variable, that is the scope of the variable. So normally the scopes in C is divided into three different types. Three different scopes are available. Three different scopes are available for the variables in C. The first one is the local scope, and there is a function scope. Then there is a file scope, or also known as global scope. So local scope, function scope, file scope, or the global scope. So local scope is a block of statement in C is surrounded by curly braces. That we know that whichever be the block of the statement, if it is the main function starts with a curly braces and ends with a curly brace, an opening curly brace as well as a closing curly brace. If it is an if statement, if there are multiple statements within an if statement, it also starts with a curly brace as well as ends with a curly brace. So all the block of statements in C are surrounded by this opening curly brace as well as closing curly brace. We can declare variables inside any block, and it should be, the declaration of these variables should be just after the opening curly brace. The only condition is that the declaration of the variable should be just after the opening curly braces, and those variables which are declared inside a curly brace is known as a local variable, or the variables with local scope, and it can be, that particular variable can be referenced only within the body of that particular block. That is, whenever that closing curly braces for that particular opening curly brace is appearing, at that point the scope of that particular variable ends. That is, only within that opening curly brace as well as the closing curly brace that particular variable can be accessed. So that is why it is known as a local variable or a variable with a local scope, because the availability of that particular variable is limited only within that particular block. So when the control reaches the opening brace, these variables come into existence and get destroyed as soon as the control leaves the block through the curly brace. So that is, within that particular opening curly brace as well as closing curly brace, that particular variable is available, and those type of variables are known as variables with a local scope. So like suppose we have some statement like this: while flag, when flag is positive or flag is not 0, this particular lines of code will run. So int x, we are defining an int x, and if I is greater than x, some variables, we don't know what is I, but some variables, if I is greater than x, then again another curly brace starts. Int j, some another codes are also there. Then the curly brace for if I is greater than x, that closes. So this here it closes, and here the while loop also closes. So the scope of the x, the variable as x, the scope of the variable x is within the entire while loop or while block. So the while block starts from here to this position. So this is the while block. So the int x or the variable x is available within the entire block of while, and it is obviously available within this particular block also. This particular block also, the x value, the x is available. That you know that we have already seen, or we have already tried programs of this type. Then the scope of j is only in the if block. The j, the variable j is declared within the if block. So the if block starts from here and it ends here. So j is described, or it is defined within this particular block, within the if block. So j is available only within this particular block. If you try to access j, the value of j outside after this particular closing curly brace, it won't give you, it will show an error, because j is not defined outside this particular block. So the variable x can also be referenced to the referenced in the if block, because this block is completely engrossed in the while block. The most of the formal parameters in function has local scope. The formal parameters that we normally pass to a function, the parameters that we normally pass to a function has local scope within that particular entire function. Within the entire function, the availability of that particular variable will be there. So that is the local scope, that is within that particular function it is available, or within that particular block of code it is available. So that is why it is known as the local scope. Then the function scope. The function scope pertains to the labels declared in a function in the sense that a label can be used anywhere in the function in which it is declared. So if we declare a function, if we declare a particular label or an identifier in a function, if that particular identifier can be used throughout the entire function, then it is known as a function with a variable with a function scope. So whatever functions, whatever variables that we declare just after the function header, is having the function scope. Like in the int main, after the int main, just after the statement, the header, the int main statement, then we start a curly brace. All the variables that is declared after that particular curly brace is having a function scope within the main. Within the main function, it is having the complete availability. So that is the case with the function scope. Then there comes the file scope or global scope. So the global variables or the file variables, these variables are declared outside all the blocks. It is done outside, even outside the int main. It is declared outside the curly braces. Outside the curly braces of all the functions that is available within that particular file. So they are available to all the blocks and all the functions. So if a particular variable is defined or declared before the starting of the header for the main function, that is int main. So normally we start with int main. So whatever is declared outside this int main, those variables will be having a global scope, that is the file scope, that is within the entire file, that particular variables will be available for all the functions that is available within the file, as well as all the blocks of codes that is available within the file. So the scope of global variable is in the entire program file. This type of scope is known as file scope, since it is available within the entire file. That is why it is having a file scope. Then this is an example of file scope. So say this is int, quantity, qty and rate. So this particular definition, this particular variables are defined before the main function. Here is the main function, and within the main function we have defined two more variables, int gross as well as net. So these two functions, qty as well as rate, these two variables, this qty as well as rate, these two are having a file scope or a global scope, or these variables can be known as called as global variables. But these particular variables, gross as well as net, they are having the function scope because it is available within the main function only. But this qty as well as rate will be available for this particular function also, fun. So if this particular function is defined within the same file, is written within the same C file as that of this code, then obviously the qty as well as rate, those will be available within that particular function. But this char c, there is a variable declaration, that is char c. The char c, this c will be available only within the function. So it is a function, it is having a function scope. And there is another variable that is declared within a block of code. So that is int a. So that is a local variable because it is available only within this particular block of codes. So global variables, rate and quantity, has the file scope, while gross and net as well as char c are having only the function scope, as well as int a is having only a local scope. So that is the three categorization of scopes for variables. Now coming to the storage classes. The storage class of a variable specifies the following: the place, that is where this particular variable will be stored. So whether it is that particular memory will be stored, I mean the particular variable will be stored inside the memory, or is it stored inside the CPU registers. These two things, these two positions can be used in order to save data, or in order to save the different variables, the memory as well as CPU register. If you use the memory, the accessing of that particular data will be bit slower, but if you use CPU registers, the accessing of the data will be very fast, but the problem is there is only a very limited space available in the case of CPU registers. So normally what we do is we normally store almost all the data within the memory, that is the RAM, and that is known as the memory. And in the CPU register, it is not the RAM, it is within the CPU itself, the memory that is available within the CPU, that is only very limited, and the RAM is somewhat having a higher capacity than the CPU registers. Then it describes, or it gives out, the storage classes gives out what should be the initial value of the variable whenever, or the default initial value. So whenever you are declaring a particular variable, it is being allocated to some space, some memory space. It may be, the memory space may be in the CPU, or it can be in the RAM or the memory, or it can be in the CPU register. So when that particular memory is allocated to that particular variable, whether that variable takes the value that is already written within that particular memory locations, or whether it rewrites the data within that particular memory location, that is the default initial value. We are not initializing the value, but we are just declaring a particular variable, say something like int x. We are not initializing x equal to some value, but we have declared x. So x is allocated with some memory locations. So whether there will be, in most of the cases, there will be something stored within that particular memory location. If we doesn't initialize the variable x, then whatever the value that is available within the memory location will be allocated to x, and in most of the cases it will be junk values. So some storage classes initializes these variables by default. So what will be the default initial value of the variable? That is also described by the storage classes. Then in which functions the value of the variable would be available, that is the scope or visibility of the variable. So that we have already discussed about what is the scope of the variable. The scope of the variable is also known as the visibility of the variable. So the storage class defines the scope or the visibility of the variable. And then the next condition is the lifespan of the variable, that is how long the variable would exist. How long the variable would exist, that is the lifespan of the variable. So that is the four different things that is provided by the storage classes. In the case of data type, when you are defining a particular variable, you have to give a data type. That is a compulsory thing. The storage classes are not compulsory, depending on the position in which a particular data type is defined, a particular variable is defined, the storage classes can vary, but the data type is you have to define, or you have to give a data type for the variable, that is compulsory. And the data type, actually what it provides is, it provides how much memory will be allocated for storing or for holding the value that will be assigned to that particular variable. But in the case of storage class, it gives all these four different cases. Now let's see what are the different storage classes that are available. There are four different types of storage classes available. One is automatic, second one is external, the third one is static, and the last one is register. And for each of these, in order to define these different types of storage classes, there is a keyword associated with each one of them. For automatic, we have to use the keyword auto, AUTO. For external storage classes, we have to use the keyword extern, EXTERN. For static storage class, we have to use the word static, the keyword static. Then in order to use the register type keyword, register type storage class, you have to use the keyword as register. So these are the 4 different storage classes that are available within C. So now let's see each one of them one by one. How the storage class specifier is used. The storage class specifier is used to tell the compiler how the variables that follow should be stored, that we have already discussed. Then the storage classes are defined or are used within a particular program in this way, that is storage class specifier, whether it is auto, whether it is extern or static or register. Those are the 4 possible values for this storage class specifier. Then the data type. The data type can be integer, float, character, or whatever it is, long, etc., etc. Whatever available data type, all those data types is possible. Then the variable list. The variable list is, the name of the variables or the identifiers that is used in order to store the different values which is to be used within a program. So in many cases, not just sometimes, in many cases the storage class associated with a variable can be established simply by the location of the variable declaration inside the program. That is, where, in which position, that is whether that particular variable is declared outside the main function or outside all the functions, or whether it is declared inside a specific block of code. Depending on that case, the most of the storage classes specifier can be defined or can be accessed even without saying that this particular variable is of this particular type. So we will see some examples. So the first one is automatic storage class. So in the automatic storage class, the storage goes to the memory, that is the value that is being used here, the value that is being stored is will go to the memory. It is not in CPU registers. Then the default value will be garbage value. Garbage value is no specific meaning. The value will be having no specific meaning. Then the scope of the automatic storage values is, it is local to the block in which the variable is defined. So it is actually having only local scope. The lifetime is till the control remains within the block in which the variable is defined. So these are the 4 aspects of automatic storage class. That is, the storage is within memory, the default value is the garbage value, the scope is, it is local to the block in which that particular variable is defined, that is, it is having only a local scope. Then the lifetime is till the control remains within the block in which the variable is defined. So now let's see how this is being done. Or most of the variables that we commonly use in our programs, they are automatic type, that is automatic storage class. You don't have to, we rarely see the keyword auto in a program. Most of the cases we are not using, in 99.99% of the times we will not be using the keyword auto, because almost all the variables that we declare, unless and otherwise specified, it is of type auto. That is why we doesn't use the keyword auto in this case. So now here is a program in which case the main function comes up first. So there is an int I. The auto keyword is not used here, still it is an automatic type variable. Then there is a variable, a character type variable, that is the storage class for that one is auto. So an auto storage class is used here, char c, then a float f is also used. Then we print the values %d, %c, %f, that is I, C and F. All the values that is being stored inside these particular variables. We haven't initialized the variables, we have just declared the variables and what will be the values that will be stored within the variables that we can see. That is the first thing. Then after that we declare another variable int a equal to 10. That is outside, that is within the int main, we are declaring another variable that is int a equal to 10. Then we start a block of code just for the sake of representing or giving out the local scope of a variable. So int a equal to 10 we have defined here, and within the block of code we have initialized another variable int a equal to 20. So here int a equal to 10, and within this particular block of code there is a variable that is int a equal to 20. And then there is another integer variable that is int b equal to 30. Then within the block itself we print the value of a. The value of a will be printed here. So obviously the value of a here will be 20. And then after the block of code again we print the value of a. We have to see what will be the value of a, whether it is 10 or whether it is 20. So that we will see. Then again this thing we will be doing after executing this much, we will try to print the value of b also. Since the b is allocated inside or it is declared within the block of code, whether it is available outside the block of code, that we will check. So in compilation there is no error. So see, this is the things that is available when we are running this particular code, that is %d, %c, %f, I, C and F. See some junk characters, 0, A, then 0.000. So nothing special is there, whether we are using the auto keyword or not. The values that is allocated are mostly junk characters. Then in the next case we go to this particular code, that is int a equal to 10, int a equal to 20, int a b equal to 30, and a print of %da. So this particular thing %da, so with that particular printf statement is within the block of code, and that is the value that is printed is 20. And then after that outside the block of code there is another print statement, printf %da. So with this a it is printed as 10. So what does it mean? The value that is created here, or the variable that is created within the block of code, that is not available outside the program, I mean outside the block of code. So with that is that's the end of that particular program. Now let's see whether we will be able to access the value of b outside this program. The value of b is I mean outside the block of code. We have initialized the value of b as 30, that is within the block of code. We are checking whether it is available outside the block of code. So we are compiling it. So see, it shows an error. B is undeclared first use in this function. It is just because the scope of this particular b is only within that particular block, that is it is a local variable. That is why it is not available within the function main.